So hello everyone. What we do in this video is we talk about things called average and alligation, right? Now, what is average? First of all, since you're starting with this, see, when we talk of average, the first thing that does come to mind is sum of observations upon number of observations. Again, not a problem with that definition, but my question is conceptually, what is this average? Why is this used? If you have a lot of data, what you may not be able to do every single time is you go through the entire data to make a decision. For example, suppose you are working with an IPL team, the auctions are going on, and you are supposed to select a player. You might not know the name of the player, and therefore you would not need some data to make a call whether you will buy the player or not. Now suppose he's a batsman, you will have scores. What you may not be able to do is you may not be able to see all the scores that he's made so far. So therefore you would need a representative number which will help you decide by just looking at that number how the player typically plays, right? These numbers are typically called measures of central tendency. The three commonly used measures are mean, median, mode. Right? Mean is also commonly called the average. Right? Just to touch upon very quickly what these measures are. Now, what is mode? A voice in the head says the most frequent number, right? So if there is a data set, for example, marks scored by students in a class, right, out of 10 in a unit test, and say the marks are 8, 7, 8, 3, 6, 7, 8, 4, 8, 2. What is the mode? Since 8 repeats most number of times, again, there is a method of finding out the mode, there is a process, but for our purpose, this is good enough. The number that repeats the maximum number of times becomes the mode. Here 8 repeats the maximum number of times, and therefore the mode of this data is 8. So what I'm saying is, if students give this exam, there is the most likelihood of the score that students will get will be 8, right? So this is most frequent. What is median? If the data is arranged in ascending or descending order, the central value is called median. And therefore, the median will be a number where half of the data set will be more than the median, half will be less than the median, right? So what I'm saying is, I'm talking of median and mode as a physical value, as a conceptual value, right? What they mean. What is the meaning of average? Yeah. So average simply means all values becoming equal. So if I say average of 5, 6 and 7, we know that the average will be 5 plus 6 plus 7 by 3, sum of observations upon number of observations. 5 plus 6 plus 7 happens to be an 18. 18 by 3 is a 6. So what does the 6 signify? It signifies that if I redistribute 5, 6, 7 among 3 people, all of them will equally get 6, right? So if you're looking at average, one way of finding out the average could be you take a 1 from here, give it to 5. All the values become 6, and that is the average. And that is what division actually means, doesn't it? The total upon 3 means 3 equal parts. So that is the equal part that everyone will have, right? That is a mean or average. Yeah. So how will I use this concept for the purpose of my questions? See, if I say that, if I ask you the average of 90, 85, 92, 95, 93, what you're most likely to do is add them up, divide by 5 to get the average. But what I'm saying is, the average is a number where all the values will become equal. So if I redistribute them and try to find a number where the total can be equally distributed and there is nothing extra that is left, that would also be the average. For example, suppose I assume the average to be 92. So in school you did this as assumed mean method. Suppose 92 is what I assume to be the average, and therefore each number has to become a 92. Now if I look at individually, here there is a deficit of 2 marks. 90 would need 2 marks from someone else to become 92. Here there is a deficit of 7. Here there is a 0 deviation. 92 will remain 92. Here there is an extra of 3 marks. Here there is a extra of 1 mark. I'm sorry. Right? So if I try to redistribute them, what happens? This plus 4 goes here, cancels this out, and from here what will be left is minus 5. So if I want these numbers to become 92 each of them, I am 5 short of the total, right? And therefore how can I equally divide them? I take this minus 5 and equally divide them amongst all of these numbers. So minus 5 amongst these 5 values will be minus 1 each, and therefore what I can do is I can make all the numbers as 91. How you would have seen this in school would be the sum of deviations from the average is 0. So if you look at the deviation of each of these numbers from 91 and add them up, they will be 0, right? Outrightly, this doesn't look very convincing. I mean, come on, I could have added and divided by 5, that was good enough. Why do this? This becomes very useful then where there is a missing number, right? So what I'm trying to say here is, suppose if I say that there are 6 values, 5 of them are known, the 6th one is not known, and I want that the average of all of these numbers should be, say, 90. What should be the value of the 6th number? G. Typically, what you would do is you'll say let this value be x, and therefore 90 plus 85 plus 92 plus 95 plus 93 by 5, oh sorry, plus x by 6 should be equal to 90, and I solve for x. No problem with that. But if I use the concept of deviations, solving a question like this becomes a lot easier. So what I'm saying here is, sorry, I ended up here. I want the average is 90, so let all the numbers be 90, right? So if all the numbers become 90, what are the deviations that I have? The 90 is a 90, not a problem. 85 has to become a 90, so 85 needs 5 extra and therefore a deviation of minus 5. 92 has 2 extra, therefore a surplus of 2. 95 has 5 extra, therefore a surplus of 5. 93 has 3 extra, therefore a surplus of 3. And then there will be some deficit or surplus here in the last case. Now what happens is, I take this plus 5 and give it to minus 5. So both these numbers among themselves become 90. And therefore I have an extra 2 and an extra 3. These 2 and 3 will be used to bridge the gap for the last number. So if I want to cancel plus 2 and plus 3, I'll need a minus 5. So this value has to be 5 short of 90, and therefore this value would be 85. With a bit of practice, you will see that doing this takes a lot lesser time, right? And in a lot of word problems, you will see that using the concept of average the number becoming equal is easier to solve, right? So I'll just pick up some examples for that. Yeah, so when numbers, for example, if I say average weight of a group of 11 students is 54.6. If a student of weight 78.6 joins the group, find the new average. Yeah, so what I'm saying here is, one method of solving it could be going with the formula for average. So average of 11 is 54.6. So the total weight of the 11 students, becomes 11 into 54.6, because average was total upon n, and therefore the total will be nothing but average into n. So total weight of 11 students becomes 11 into 54.6. Let the weight of the 12th person be x, and therefore the total of the 12 students will be 11 into 54.6 plus x. I know 78. I want the new average. Okay, sorry. A bit problem on my end. I know this. Sorry. Yeah. So we have the average of 78.6. The weight of the 12th person 78.6. Therefore, the total of these people becomes 78.6 plus 11 into 54.6. We have to find the new average. So I simply divide this by 12 to get the new average. The division and addition might take time, and therefore, if I use the concept of average, meaning all values becoming equal, what I can assume is that the 11 students that are there individually have a weight of 54.6, and therefore their average will be 54.6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 kids, each of them having a weight of 54.6. Of course, you don't have to write this, but this is what I'm assuming. A new person comes in, he has a weight of 78.6. Now, whatever extra weight that he has will be distributed amongst everyone in the group, in the new group. What is the extra that he has? He has a weight of 54.6, which is the average or the value with each one of them, plus an extra of 24. So when I include this person in the group of 12, each of them will have 54.6, plus there will be this 24 extra. This 24 will now get distributed amongst the 12 people, and therefore I say the new average will simply be 54.6, because this is what everyone has, plus the 24 divided amongst 12 people, which is 2, and therefore the average becomes 56.6. Right? The amount of calculation reduces drastically. If you look at further questions related on this, for example, look at this question. If the average weight of a group of 10 students is 50, when one student joins the group, the average is increased by 1. Find the weight of the new student. So what happens is there are 10 people. Each of them has a weight of 50 kgs because the average was 50. Right? A new person comes in, and because of this person, everybody's weight becomes 51. Right? What is the extra that the new person will have is the question, and therefore we can find out his total weight. Yeah. Now, if I assume that right now x has a weight of 50, when I've included x, actually everyone has a weight of 51. So all of these people have 1 kg extra, and therefore the weight of the person that joins in is 50, because that is what everyone had, plus he had 1 kg to distribute to all the 11 people, the 10 in the group and the one he was joining, and therefore his weight would be 61 kgs. The other way of looking at it could be, when the person joins in, the weight of the 10 people who are there becomes 51. So this person, and at this point in time, everybody's weight is 51. So the person who has joined in has to have a weight of 51, plus he will give 10 kgs to the people who are sitting there, 1 kg to each, and therefore his starting weight has to be 51 plus 10, 61. Either this or this, whatever you think is more intuitive to you, could be used. But the point is, average means all values becoming equal. Moving on then. Again, a question that has been asked earlier says, Sachin had a batting average of 63 runs in the first 15 matches. So he's played 15 matches, his average is 63, which means I can safely assume that Sachin has scored 63 in each of the 15 matches that he has played. The average will still be 63. If he wants to increase his batting average by 10 runs, then how many runs he needs to score in the next 3 matches? So his average is 63, he wants to take it up to 73. Not just the 3 matches that he's playing, but for the old matches as well. So what is the total score that he needs? Because After the 3 matches he has played, all the values have to become 73. So the runs that are required is, for the first 15 matches, he needs 10 runs extra for each of the innings. And therefore 15 into 10. These runs will ensure that his average that was 63 for the first 15 matches reaches 73. Plus, for the 3 matches that he's going to play, he still needs 73 in each of those innings. Therefore, plus 73 into 3. And that will give you the answer. So 150 plus 219, which becomes a total of 369. That is how the simple logic, which says average simply means all values becoming equal, can be used to solve a lot of word problems very quickly, or in a data set where numbers are missing, right? For example, this is a previous CAT question. I think it was a question CAT 2007, not the exact format. When it was asked, it was based on data sufficiency. So yeah, let's just have a look at the question quickly. It says the average weight of a class of 100 students is 45 kg. The class consists of 2 sections, 1 and 2, each with 50 students. The average weight W1 of section 1 is 1 kg less than the average weight of W2 section 2. If the heaviest student, say Deepak of section 2, is moved to section 1 and the lightest student of, say, Poonam of section 1 is moved to section 2, okay, then the average weights of the 2 sections are switched. The average weight of section 1 becomes W2 and that of section 2 becomes W1. Moving Deepak from section 2 to 1 without any change from 1 to 2, that is without moving Poonam, makes the average weights of 2 sections equal. What is the weight of Poonam? So if you look at this question, it does appear to be an RC question, right? But if you go out to solve this, conceptually you'll realize there is not too much calculation here at all. Now, there are 100 students, 45 kg. So what I'm saying is, section 1, section 2, this has an average weight of W1 for 50 students. This has an average weight of W2 for 50 students. When Deepak goes from here to here, the average of both the groups becomes equal. Here now there are 51 students. And in this class there are now only 49 students because one student has gone from here to section 1. And if you take Poonam after this to section 2, the number of students here is 50 and here again it becomes 50. We have to find the weight of Poonam. The first thing that I want to do is find the value of W1 and W2. It says W1 and W2 have a difference of 1. What will be the value of W1 and W2? So if I look at this, I see that I am not able to find W1 and W2 directly. Okay, so I'll go to what I know. I'll just equate the totals. So the total weight of students in section 1 will be 50 into W1 number into weight, plus the total weight of students in section 2 will be 50 into W2, and this should be the total weight of the entire class. The entire class is 100 students with an average weight of 45. Further, right? Next, I know the relationship between W1 and W2. W1 is 1 kg less than W2. So W2 is basically W1 plus 1. So I put that value here, 50 into W1 plus 50 into W1 plus 1 is 4500, which further gives me 100 into W1 plus 50 is equal to 4500, which further gives me W1 as 4500 minus 50 will be 4450 divided by 100 will be 44.5, right? and therefore this will be 45.5. And all of a sudden, my eyes open up and I realize I could have done this without actually writing this entire formula or the equation, right? See, there are two groups which have equal number of students. The difference between them is 1 and the overall average is 45. Can I say that the average of each of the group will be equally distant from 45? Because the entire difference is 1, so there has to be a difference of 0.5 here and a difference of 0.5 here. And therefore directly I could have written 44.5 and 45.5. No need of that entire equation. Right? Of course it did not strike me in the first go. झूठ बोल रहा हूँ, मैं घर से prepare करके आया था. But yeah, once you have written this, it should strike you that this could also have been done. Next, at this point, the average of the two groups are equal. The overall average is 45. What should be the group of what should be the average weight of each section? If there are two sections which have the same weight, average weight, and I combine the two sections, the overall average will still be the same, right? For example, if you have two solutions the same concentration, if you mix them, the concentration does not change, it remains what it was for the each group, and therefore here the average has to be 45 and 45, the average of the overall group, and at this point it changes to 45.5 and 44.5. So just combining these two, I can find out the weight of Poonam, right? Because when Poonam comes to this group, earlier at this point when Poonam was not here, this group had 49 students, each having a weight of 45. The moment Poonam comes in, everybody's weight becomes 44.5. That means Poonam would have taken half a kg from each of these students to reach 44.5, right? And therefore, I can say Poonam plus half a kg from each of the 49 students is Poonam's new weight 44.5. This becomes 24.5, subtract, therefore Poonam becomes 20. So technically speaking, the only calculations required were this and this. The rest is just putting the data properly, right? When the question was asked in the exam, it was a data sufficiency question. One of the values were missing and you have to find out which information is required to answer the question. But I think a good conceptual question to understand whether you know averages or not. Also, if you look at the previous year, 2 or 3 years questions that have been asked on average, some of them have been very basic, but there have been a couple of questions which talk about the maximum minimum average of the groups. So either the number of people in a group, a subgroup rather, or the average value of a subgroup is not given. There is a range and you have to find out what can be the maximum or the minimum average for the entire group. That kind of questions have been asked, which we'll take up in some other section or some other video. Right now, what I want to touch upon is the concept of alligation. It's a very powerful concept. A lot of times, people tend to talk about alligation as something that you use to solve averages, but please understand, alligation finds application in a variety of questions, right? Last of them being mixtures. What is alligation? Now, if you look at this question, where I say there are two sections, A and B, each having 50 students, the average marks of the first group of students is 70, the average marks of the second group of students is 30. What will be the overall average of the class? So probably what would come to mind is, okay, let us use the formula for average and see what happens. The total score for students in section A, total for section A would be 50 into 70. The total for section B would be 50 into 30, right? And therefore the total for the entire class would be total score of the students plus the number of, upon the number of students, 50 plus 50. This is the calculation that I'm trying to do. I divide the entire thing by 50, I'm left with 70 plus 30 upon 1 plus 1, or 70 plus 30 by 2, which happens to be the average of 70 and 30. right? Why does this happen? Because the number of students in each class was same, right? So if I look at a score of 50, every student here has 20 marks extra. They take those extra marks, each student, and gives it to one student here. So 70 reduces by 20 becomes 50, 30 rises by 20 becomes 50, and therefore one student from section A, one from section B, all of them average out to 50. This is average, right? What is weighted average? If the number of students change. For example, if I look at the second situation, there are 60 students in section A, 40 in section B. Average marks of the first group of students is 70. The average of the second group of students is 30. What will be the overall average now? So again, what you can do is you can use the formula that we used before this. You can say, okay, the average will simply be number of students in the first section into average marks. So total marks of the first section plus total marks of the second section upon number of students in each section. That is all I have to calculate, right? But conceptually, if I ask you, will the average be the same as 50, more than 50 or less than 50 in this case? Because there are more students who have scored 70 marks. What happens is, I take a student from this section, ask him to give 20 marks to a student in this section, right? So 40 students from here will come down to a score of 50. All of these 40 will increase to a score of 50, right? But I still have 20 students left who have a score of 70. And therefore my overall average will go beyond 50. So what I'm saying is, in case of average, we said if there are two values which have an equal weight, the overall average will be the center of these two values. They'll equally divide the difference. But if the number of students here is larger, here the average score is 70, here the average score is 40, and the number of people here is more, the average will tend to shift towards 70. That is the idea of weighted average. The average is closer to the number which has a higher weight or higher representation in the overall data, right? You know this because you know of fulcrums, right? You probably would have sat on a seesaw. Suppose if I put more weight on one side of a bar and I want to balance this bar, from where do I need to support it? I'll have to support it closer to the higher weight, right? If sitting on a seesaw with your friend, unless you have the same weights, it will not balance out, right? Something like that. Now, how do I solve? To solve weighted average, the concept of alligation can be used, right? How does that play out? See, what will still remain the same is the fact that average means all values becoming equal. So if I say that the overall average is x for the entire class, this x will lie between 70 and 30. What will be the overall surplus that I have? Since each student in section A has 70 marks and they want to be left with only x, the total surplus that I have will be 70 minus x, and this is with each of the 60 students. What is the total deficit that I have? Deficit will be with students in section B. Since they have 30 marks each and they want to get up to x, the deficit will be x minus 30. This will be with each student of the class, therefore 40 into x minus 30. The total surplus has to be equal to total deficit because the deviation from average is 0. So what I get is 60 into 70 minus x is equal to 40 into x minus 30. This can further be written as 70 minus x upon x minus 30 is equal to, this comes down, so 60 comes to the right hand side bottom, 40 by 60. The pictorial representation of this equation is called the method of alligation. Three points to be noted here. One, x has to be a value between 70 and 30. So both these differences will be positive or negative depending on what you subtract which number from. Point number one. Second, the difference of the average from one of the values will be proportional to the number of the other students. That is 70 minus x is proportional to 40. 70 minus x proportional to 40 and x minus 30 is proportional to 60. Point number two. Third, whether I write 40 by 60 or I write 4 by 6 or I write 2 by 3, the value of x will still remain the same. And therefore, on the right hand side, all I need is the ratio of the number of students. The exact number does not really matter. Right? So what I'm saying is, to solve this, I'll say, okay, 70, 30, the individual scores, x is the average. I take the difference here. This difference has to be proportional to the number of students, 40. And this difference has to be proportional to the number of students in the section A, which is 60. This is how alligation is solved. You can have 3 questions broadly for each. You will apply alligation. So just quickly touch upon those questions. For example, the first question here, the number of students in section 1 is given as 60. The number of students in section B is given as 40. The average marks of students in section B is 30. The overall average of the class is 54. You have to find out the average marks of students in section A. So what I do is, I use alligation. I say, let this value be x. The other value is 30. The overall average is 54. Right? And the number of students who have an average of x is 60. The number of students who have an average of 30 is 40. I take the ratio of these two numbers, which is 3:2. Right? Now the difference of 30 from the average has to be proportional to the number of students in section A. So I take this difference. 54 minus 30 is 24. The differences have to be in the ratio 3:2. If the value on the right hand side is 24, what should be the corresponding value on the left hand side so that the ratio is 3:2? Because 3 8s are 24, I multiply 2 by 8, so difference here has to be 16. Okay. Also, since 30 was less than 54, the other value has to be more than 54. So you take this 16, add to 54 and get a 70 here. This is when the score of one of the class is not given. The second question would be, you have the average scores of the two class. You have the average overall score. You have the number of students in the first class. Find the number of students in the second class. Again, write the scores at the top. The overall score or the overall average in the center, take the difference. 70 minus 54 is 16. 30 minus 54 is 24. The ratio of differences has to be the ratio of number of students. The ratio of difference is 3:2. I know that the number of students in the first section is 60. This ratio of number of students has to be 3:2. If 3 becomes 60, which is 20 times, 2 will become 40, which is 20 times, and therefore the answer here becomes 40. Either the score of one of the sections is not given, or the number of students in one of the sections is not given, or the third question could be where the average is not given, something that we started from. Sorry. So here suppose I give you that this is 70 and I have to find out the overall average. In these questions, it is sometimes a good idea to actually just write the equation and solve. For example, I write 70 minus x upon x minus 30 is equal to 40 by 60 and solve for x. This could be a good idea because this will work every single time. Or you can just write the average formula for weighted average that we had written, 60 into 70 plus 40 into 30 upon 60 plus 40. Both of these will work every single time. But sometimes, given the numbers, Another method can be used again. The concept of alligation, I say 70 and 30. The number of students is 60 and 40. Find the ratio of number of students, which comes out to 3:2. Right? Now what I do is, I look at this difference between these two values, which is 40, and divide it in the ratio 3:2. 40 in the ratio 3:2 would be, because 3 plus 2 is 5, 40 by 5 becomes 8, 8 into 3, 24, 8 into 2, 16. Now you take this 16 and subtract it from the larger number, or you take this 24, add it to the smaller number, you get 54. This will work. Where it could create a problem is when the difference is not divisible in this given ratio, or you're getting a decimal. There it might create a bit of a problem. In those cases, this or the formula for weighted average would be a better idea to solve. So this is alligation per se. Why alligation is useful? Because it finds application in a lot of areas. Of course, mixtures is something that you will keep seeing alligation being used, but what I'm saying is, for example, a mixture sort of a question where two different prices are mixed. Find the ratio in which rice at rupees 72 is to be mixed with rice at rupees 57 to produce a mixture worth 63 per kg. If you solve this using equation, it takes a lot of time. Suppose if I say x kgs of this, y kgs of this, then the equation will become 72 into x, total cost, plus 57 into y, total cost, upon x plus y, total weight, is equal to the average price. You solve, you'll get a ratio of x and y. Again, takes a bit of time, and therefore alligation becomes useful. Two types of things are mixed to get an overall price of 63. Just take the difference. And therefore, the ratio of weights have to be 6:9, which is nothing but 2:3. That is how alligation can save you time in a lot of questions, right? What is interesting about alligation is, alligation finds application in a lot of different areas. For example, in questions based on time, speed, distance, in questions based on simple interest, compound interest, questions based on profit loss. There are a lot of areas where alligation can be used to find the answer, because anywhere where two different kind of things are mixed to get a central sort of a value, alligation will become useful. For example, look at this question. So it says 1/3 of goods worth 1200 are sold at a profit of 10%. At what profit should the remaining be sold to get a overall profit of 20? Sorry. So what I'll do is I'll say, okay, say the profit on the remaining is x%. The equation that I'll get is 1/3 of this, that is 400 rupees worth of goods are sold at 10% profit. I have to find the profit on 800 rupees worth of goods for an overall profit of 20%. I can do this point by point. That is, overall profit I find out. I get the profit here. I know the profit here, and then I solve. Right? Again, not a very difficult question. If you gone through PLD, should be able to solve it pretty simply. Or you could write the equation and say profit will be 10% of 400 plus x% of 800 upon the overall cost price 400 plus 800, and this should be equal to the overall profit, which is 20%. Right? If you look at this, this is the exact representation of a weighted average. Marks into number of students plus marks of the second into number of students upon the number of students is equal to the average mark. So here two different things are mixed. One has 10% profit, the other is x% profit. Overall, I'm getting a 20% profit. So I could use alligation as well, right? As you can see, the weight attached to the percentage profit is the cost price. So I write 10 profit on percent on the first part, x profit percent on the second part, overall profit of 20, and the ratio of cost price is 400 and 800, which is a ratio of 1:2. The difference here is 10. If I want the difference of ratios to be ratio of differences to be 1:2 and 2 becomes 10, 1 has to become 5. Simply add 5 to 20 to get 25 as the answer. Becomes a lot easier. So what I'm saying is, whenever you're mixing two different kinds of things, the overall value can be found out using alligation. And again, a lot of areas where it can be used, which we'll talk about in the coming videos. All right. So thank you very much. It's an important concept in terms of papers, average, and the application of it, which is alligation. Definitely, if you are looking at questions in the past 3, 4, 5 years, you'll see these are questions that are very doable and will find application in the paper as well. So something that you should look at a little seriously. All right. Thank you very much.